Now that we understand the principle of multiplying exponents of like bases, we can apply it to some of these problems. So let's go over a few examples in section 7.2. The first is 5 to the negative second power times 5 to the 7th power. As you can notice, we have like bases here, so we're just going to copy the base again. Now we get to the part where we look at the exponents, and we're going to add them because we see multiplication. So we have negative 2 plus 7, and then we can write our final answer, which is 5 to the 5th power. If you want, you could simplify that a little bit further by actually typing that into a calculator, but we're good for now. Let's do another example. Here we see, even though the bases are a little odd, we're going to keep the base the same, 0.5. We can keep it in parentheses also. We have exponents, so what we're going to do is we're going to add the exponents together. So we have negative 3 plus a negative 4. A negative 3 plus a negative 4 makes it more negative, so we get 0.5 to the negative 7th power. And that's our final answer. Again, we could simplify it further on a calculator if we needed to. Now, what about when we have 3 terms? Same thing. As long as we have 3 like bases, all we need to do is add the exponents together. So we add and we add. So now we have 9 to the negative 3 plus 2 plus 7th power. And that equals 9 with our base. Negative 3 plus 2 plus 7 gives us 6. So we have 9 to the 6th power. And that's going to be our final answer. The next set of examples are a little bit more tricky because now we have some coefficients mixed in. I assure you that the coefficients just make it a little bit more extensive, but nothing too complicated. So we have 4 and 9 as coefficients. I underlined them because we're going to be doing something with those later. And then we have our like bases with exponents, z to the 5th and z to the negative 12. I always start with the coefficients. I think that's the easiest. So we're going to go ahead and multiply 4 times 9, which gives us 36. Then we have z to the 5th times z to the negative 12. What we're going to do is we are going to add exponents here. So we add because they have like bases. And we're going to get z to the negative 7th power. And that's going to be our final answer. Same process applies over here, even though we have multiple terms. We're going to underline our coefficients, the numbers without any exponents. We're going to underline a's. Anything with an a, that's going to be a like base. And then b is going to get its own set of lines right here because that's different. First, I always multiply my coefficients, 2 times 9 times 3. That should give me 54. My a's. Now, the temptation is to write a times a squared is just a squared, but that's not true because a squared times 1 would give me a squared. So a times a squared needs to be different. How is it different? Well, there is an implied 1 there. So if we add the bases, add the powers, we should get a cubed. So our answer needs to be a cubed. The b to the 4th, he doesn't have any buddies, so we're just going to keep him by himself. And that is our final answer. Moving on to our last and toughest example, we have 2 sets of terms here, but it's all multiplication, so we don't need to worry about doing anything funky. I'm going to first underline all my coefficients. Technically, there's a 1 in front of that a, but since it's not there, we don't really need to worry about it. And then we have a's here. We have some b's here. So we can go ahead and multiply all of our like terms. So we have 2 times 3 times 5. That will give me 30. So equals 30. Now I have a to the 2/3, and I'm going to be adding the exponents. So let me zoom in here. That should be a 3. Plus, what was the other exponent? 1/3. And then my b, I think, is 1/4 plus 1/2. Okay, so now I move on, equals 30. A to the 2/3 plus 1/3. 2/3 plus 1/3 equals 3/3, which is the same thing as 1. So it's a to the 1st power. 1/4 plus 1/2 for my b exponents. Well, I need to find a common denominator. I'm going to change it to 2 over 4 plus 1 over 4 equals 3 over 4. So I'm going to change b to the 3/4 power. Now, I don't really need that 1 there if I don't want, so I could either write it like this, or I could write it without the 1 with for the exponent for a. So either of these will work for my answer. I hope this was helpful for you. Make sure to rewind and watch parts that were confusing or I went too fast. Leave a comment if you need some additional help on anything, and I hope you enjoyed this video. See you next time.